Welcome back to Fusion. This is a video on measuring. We've already uploaded a step. You can see here. You don't have to watch me doing it, but it is from the step, and we're off to the races. Just hide that. We'll look back at it later. Here's our bit. Now we've done this already, and we would like to generate it, say, if we give it to somebody else. It's easy to measure things just by clicking on them. So for example, if you click on some shape, in this case a circular edge, you can see down here at the lower right, it does highlight or show us what we've got here. One edge, selected diameter, irrational number. Click a different one, and we can see here, that's 5. That's a rational number. It becomes a little more difficult if we're trying to figure out, for example, the distance between these two guys. It'll do its best. Like, it's not bad, right? So you can get quite far with this. But it does require you to spend quite a bit of time clicking back and forth, and usually some sort of notepad, keeping track of all the dimensions, or you do them one at a time, which is very tedious. Measure is I, shortcut. It's a bit more complicated. You can have, for example, secondary units turned on. You can see the precision, change it to whatever you wish. In millimeters, which is our standard 3 decimals is fine. And snap points shows all the bits or places that we can select overtly, or midpoints, middle points, all that stuff. Makes it a little easier. So for example, you can see 3 millimeters. It labels it right on the spot, which is good. Kind of works not bad. You can see deltas. So for example, if you want to see the distance between these two vertexes, you can ask for deltas. Kind of great. So you can select 2 things and get a lot of measurements off of it. It's not bad. There's 3 different types of coordinate systems. However, it's fine, but it doesn't get past the problem of just collecting a bunch of data, probably on a separate little notepad. One solution to this is actually to sketch right on the step file. So we know that there's usually a sketch within these things. We're going to split the part. So search for split body, pick the body, and pick a face to split it with. Now, normally, hopefully, the person who modeled this used the datum planes. So let's use one of those. So splitting tool, let's pick the ZX here. Now we already made this part, so we know the sketches are on this. Say OK. One thing that the problem is here, for example, we know that this here is a radius. So it's a swept sort of revolve, if you want to think of it that way. One problem is that we cannot get that directly mapped onto our sketch. So keep that in mind while we're working away here. We're going to come back and split it again. We have 2 bodies. If your bodies are not open, just open them in the browser. Nice. Now, one thing that we want to do, or you don't have to do this, but one way to make this easy is to make sure that you're auto-projecting sketches. I'm going to put a sketch on this face, and I need to make sure that my preferences are correct. If we go into design, auto-project edges on reference, that's for projections. But the one that we want to see is auto-project geometry on active sketch plane. So we want that. Say OK. Right click on this guy, create sketch. What you will, it's sometimes hard to see, but sometimes you'll see the sketch will be right there. So there's our sketch with the edges intact. Nice. So not bad to see the body. We can add, for example, there's no center line. We know it's a revolve, so we can actually add our center line and turn it into a center line. This will allow us to dimension. So using the D tool, 7. Now, over constraint. We know this is over constraint because we're just dimensioning something that already exists. Do not show again. It's not really diameter, but it's close enough. Now, what do we have here? So this is that hex drive. Now, if we just measure across here, we should expect to see 6.35, better known as a 1/4 inch. That's all fine. See, these are the same. But how do we find this right here? So I'll finish the sketch. Now, all the dimensions disappear. Right click on sketch 1, show dimensions. It's kind of good. Now, what I'm going to do here is create another split. Turn the bodies back on. Hide the sketch for a moment. I want to split through, say, this. Can I arrange it so that I can see things? So the problem is sometimes you cannot get everything at once. I want to be able to see this shape and this diameter. So if it's worth it to you, you can do a separate split and figure out what this is. But it's probably not a bad idea because we've also got this slot. So let's do a couple of more splits. I'm going to split this front body, which I wasn't using yet. So this is the one we were using. Let's split this guy. Split the body again. Turn on our axis, our planes, our standardized planes. Let's split this body with that ZY plane. Let's keep that one. That shows us what we want to see. And last but not least, we need to split this guy again. So let's split this once to get this part. We don't have a plane available yet. So first, plane at an angle, line. It'll pick whichever one's closest, but if we go to 45, snap. May not. We'll get some warnings here. Oh, come on up. Small error there because of the pop-up. Then do a split. Split the body one more time. Splitting tool. Hide the origin and hide the construction. Now, for example, if we want to, and we went through all this effort, let's put a sketch on this face. Dimension. Because we only have a 1/4 or a piece, an 1/8 of a part, we can turn this straight into centerline and do a dimension out to that edge, 4. That's a 3. And how far from the origin? 3.5. How far down to this guy? So whatever is convenient, like we're not asking to see these files, but this is how to cut it apart. Excuse me, sorry. Next, what about this sweep here? Wonder where it was. It shouldn't matter because if it's a swept cut, we should be able to just pick it. That doesn't seem like anything useful, but maybe it's exactly 1. Just move that up. So you can select and delete. This tells us something, not much. Maybe it tells us this. So that's what we want. So the diameter of that on the top is 2. This is a strange value. Maybe we have an angle here. Now if you remember that we do have an angle, that makes it easy. But we can add construction here. So for example, if you want, make a construction, if you want to be tidy, and then dimension that guy. No. So what's going on here, right? So this is our problem. So even though these seem like, once you see the trick, you think, ah, everything's solved. The problem is that sometimes it doesn't really give us what we need because of the angle. Let's go back to this first sketch. Maybe we can do it in here. So let's have a diameter, or sorry, dimension. Yeah, that's 2. So even if we rotate around, of course, it doesn't make any difference. How do we figure this one out? How about this? Ah, that's what's going on, right? So as we do this, we have to kind of try and figure out what the modeler has done. If we don't kind of hunt around a bit, we might never find it. So for example, if we look at sketch 2 right now, turn on the right body. Let's edit that. Before we had that same incorrect angle, but if we did a dimension here, it's not bad because of the angles, sorry. So if we want to have more, sorry, I'm double clicking like a crazy person. If you want to see more accurately, you can always use the information or the measuring tool. So you can see here the distance is, oh, make that bigger if I can, there we go. See, there is actually an exact value here, right? So just keep an eye on what's going on, and we'll be able to figure out what hopefully a rational person did. So there you go. That's how one approach to measuring step files with some accuracy, depending on what you need to see. So for example, the next thing would be, where's the slot? How about this waist, positions, all that sort of stuff. Over to you. Thanks for watching.